A pleasant welcome to all. Now we are going to study about scheduling algorithms. Video lecture and e-content created by R.D.Sivakumar, MSc MPhil MTech, Assistant Professor of Computer Science and Assistant Professor and Head Department of MCom CA, INAD at Janaki Mall College, Sivagasi. Mobile 0994404 42243. Email sivamscsit@gmail.com. Website www.rdsivakumar.blogspot.in. CPU scheduling algorithms. CPU scheduling algorithms decide which of the processes is the ready queue is to be allocated to the CPU. CPU scheduling types: non-preemptive scheduling, primitive scheduling. Non-primitive scheduling. Once the CPU has been allocated, in non-primitive scheduling, the process keeps the CPU until it releases the CPU either by terminating or by switching to the waiting state. Primitive scheduling. In primitive scheduling, the process keeps the CPU until interrupt occurs. First come, first served scheduling. It is simplest CPU scheduling algorithm. It is non-primitive scheduling algorithm. In the scheme, the process that requests the CPU first is allocated the CPU first, or the process entered the ready queue first is served first. FCFS, waiting time. Waiting time is equal to starting time minus arrival time. Turnaround time. Turnaround time equal to finished time minus arrival time. That means burst time plus waiting time. Response time. In non-primitive scheduling algorithm, the average waiting time is equal to the average response time. Shortest job first scheduling. In this scheme, the CPU is assigned to the process that has the smallest next CPU burst. It may be either primitive or non-primitive. Primitive SJF scheduling algorithm. In primitive shortest job first, the new process may have a shorter next CPU burst than the currently executing process. It will preempt the currently executing process. Primitive SJF scheduling is sometimes called shortest remaining time first scheduling. Advantages. Comparing to FCFS algorithm, almost 50% waiting time saved in SJF. Disadvantages. Big jobs are waiting so much time for CPU. Priority scheduling algorithm. In this scheme, a priority is associated with each process and the CPU is allocated to the process with the highest priority. Equal priority process or scheduled in FCFS order. Priorities are indicated by a range of numbers. Low numbers represents the high priority. It may be either primitive or non-primitive. Primitive priority scheduling algorithm. In primitive priority scheduling algorithm, the new process may have higher priority than the currently executing process. It will be primitive the currently executing process. Round robin scheduling. It is a primitive scheduling algorithm. It is designed for time sharing systems. In round robin scheduling, the ready queue is treated as a circular queue. In this scheduling, the CPU switches between the processes when the time quantum expires. Multi-level queue scheduling. In this algorithm, the ready queue is partitioned with number of ready queue. Each ready queue has its own scheduling algorithm. 4 ready queue partitions. The first one is system process, and the second one is foreground process, and the third one is background process, and last one is student process. System process. The system process might be scheduled by an FCFS algorithm. Foreground process. Foreground process is also known as interactive process. It is might be scheduled by an short jump first algorithm. Background process. Background process is also known as batch process. It is might be scheduled by an round-robin algorithm. Student process. Student process might be scheduled by an S or J algorithm. Multi-level feedback queue scheduling. In this system, the ready queue is divided into number of queues. It allows a process to move between processes. Advantages: a process that waits too long into a lower priority queue may be moved to a higher priority queue. Multiprocessor scheduling. In multiprocessor scheduling, each processor examines the common ready queue and selects a process to execute. Thank you.